Okay, well let's just set the white balance on the blank piece of paper. I've no idea whether that will be any good, but here we have a York 863 with a sticky lid. So it's in the same batch. I've no doubt the customer's going to do some niceties to that, and it's come with the original mic. So we'll get it plugged into the test gear. I think there's 2 more in this batch, and then we might actually have to do somebody else's jobs. I'll do his mic later. We'll do his mic later. We'll use the standard replacement mic. Right, so we'll plug in the PA speaker. We'll plug in the speaker to our test gear. We have a short stubby bit of power lead on here somewhere for there we are. No, it's a full length power lead. Why is that? Right, it's an unknown set, so we'll power it up at 9 volts, 300 milliamps, current limited. It's powered up. Put it on channel 20, which we can just about see. It's drawing 166 milliamps. Select 13.8 volts, current limited for 1.6 amps. We have to set the current limit for 2.5 amps on newer sets with these CPUs that seem to run sub-squelch menus and other junk. We're running out of corners on this piece of paper, so we'll trying to keep all the customers' ones on the same one. York 863. We had one recently, didn't we? I don't think it was in this batch, otherwise he would have had 2, wouldn't he? So we'll switch picture in picture on. And let's see, we're on channel 20. RF gain up. Normal, yep. Transmit. And it is 3 watts. Deviation, wallow. 1.7 kilohertz. So far so good. It looks quite genuine, doesn't it, that? So that's going to be accurate. Yeah, a little bit low, not illegally low. 27,79095. Pull that up. Should be 27,79125. And now we will check the receiver. I'll set the receiver, the signal generator, to 27,79095, so it's a fair test. And there we have it, the same. So let's listen to what the receiver's got to say for itself. I'll switch the Cybernet meter on ready. Noisy volume control. Make sure RF gain's up. Put more volume so we can actually see it's on the Cybernet meter, which I'll put on the display. That is. Oh, this is very good. That's very good. 0.35. Don't expect we'll be improving that. Right, we'll get the lids off. That's on tighter than I would expect. I've got 15 minutes. I'm going to try and get the transmitter side of this done. having to re-edit the on the air test for the Midland 3001. Notice it was recorded on the 13th, and I uploaded it to YouTube, and then I thought, well, I'll just look at it on YouTube myself before pressing the publish button, and miraculously there was no sound on 2/3 of the test. Well, if there'd have been no picture, it wouldn't have mattered, but when you're doing these tests, so that's all having to happen again. And there's something's happening in the editing. It's not YouTube's fault on this occasion. So I can't see anything dodgy. A little bit of fag smell. My test set loves to make a racket from time to time. I think it's letting off steam. So we'll connect our earth with Mr. Chippy's clip lead. We want channel 1, and we'll get this VCO set. That's still on screen. No, it's not. I usually have it the other side on. So we want 4 volts, so we need to adjust the receive coil to get 4 volts. That's a bit out. That'll do me. It's going to transmit. And that needs adjusting too. So it's the red trimmer. Receive is 4 volts. Transmit is 4 volts. So now we need to go to channel 1. And see where it is. Have I done this wrongly? Okay, so I thought I was on channel 1, I was on channel 40, so we'll just reset that. It was probably spot on. So on receive, 4 volts, on transmit, back to receive, back to transmit. Transmit's drifted slightly. Receive, transmit. Now we go to channel 1, and it should be between 1.8 and 2.3-ish. 2.15 on receive, and on transmit 2.2.28. Excellent. Just goes to show how easy it is to not see the display. That would have been fun if I'd have sent it back like that. Radio only works on the first 5 channels. We'd have soon found out that, wouldn't we? Because we're on we do our tests on channel 31. So we're on channel 20. I've remembered to do that. And we'll go to that and we'll start tuning up the transmitter. So we're at 3 watts. So see whether that's peak. Yes. No, it is now. Yes. Then the ones you have to be pretty slick doing. As I've said before, we've got to turn the power to the maximum it can generate, and that can be beyond what the radio can sustain, so you can end up actually having smoke coming out. So we've got to be quick. So the first one has brought it up to 4.8 watts. The second one has brought it up to 4.9 watts. The third one has brought it up to 5. Recheck. Peak. Peak. Do not leave it like this. Legality aside, it will kill the radio. So it's clockwise for 4.4 watts. This balances the transmitter between the 40 channels. And then anti-clockwise, they say for 3.8 watts, but we want the legal maximum, which is 4 watts. Now we need to check it, and it's supposed to be between 0.1 of a watt between the 40 channels. So I'm on channel 1, and it's, I could say 3.95. Channel 40, I could say it's 4.85, so that's very well balanced. Excellent. Now we'll do the RF meter and we'll see what it says. And remember, this is done only into a dummy load. It's banging across and we want it to read 4, which it now does. Low power. These are usually dirty. I'm going to preempt it being dirty by spraying it first. So low power should be 400 milliwatts. I'll change the test set to the 3 watt scale. So our full scale deflection is now 3 watts. Go into power attenuation, which should be 0.4 of a watt. It's hardly moving. We'll waggle that about and can end up having to replace it. 319, yeah, it's 4, it's 0.4. There we are. Now we'll pop it onto frequency. Could have done this earlier. Won't make any difference, but I'll just check it doesn't. Let's put that on that meter for you. Or that camera, sorry. So 2779086. Need to just pop that on to 79125 if it'll go. So I've just kept it a bit high there, which is a sensible move. So it's now 4 watts, 400 milliwatts. It's now 2779127. So I'm just going to check it is still doing the right power. It is, and then on the high power range, check it's still doing 4 watts. Not quite. There we go. Deviation. Wallop. Right. Just check we're calibrated. 1, 2. One, two, wallow. We are. So, the vertical one I need for its center position, and then we'll adjust the horizontal one for the correct deviation. Let's see where we are now. Wallow. About 1.5. Hasn't really changed it. And just to make sure this mic gains up, it is. Make sure we're not on clear. We're not. So just pop that up. 1 2 wallow. 1 2 wallow. 1 2 wallow. Still needs to be a bit more. Wallow. That's it. So that's now 2.2 to 2.45 kilohertz. So the peak, you don't ever want to exceed 2.5. So we're averaging around 2.2. That's it. Good. Right, I'll see if I can put some spray into this, and we'll come back to the receiver after lunch. Right, so now we'll move on to the receiver. I'll just check it's still on frequency. Yeah. So we'll start with having the oscilloscope on, which I'll switch on, and let's make sure the signal generator is on the correct frequency, because we tested it on the frequency the radio was on at the time. So that's brought that up. 2779126. Right, so with a S9 equivalent signal of 100 microvolts, I want a meaningful trace on the oscilloscope. I'm sure this monitor's moved even more. And adjust the detector for maximum recovered audio. That's not the right tool. Yes, I've gained a bit there, so that's good news. Right, we'll drop the signal down. I'm starting with 1 microvolt, and we'll go over to the Cybernet meter. So we need to drop the attenuator, so we're currently at 1 microvolts. We'll drop the fine attenuator till we get about 4 dB. I don't think we're going to gain anything here. It's so good. On the other hand, we have to change ranges. I've now switched to the 0.3 microvolt range. Signal for the next one. Wrong tool. That's correct. Correct. I don't think that's going to have gained us anything. Let's see where we are now. So 12 microvolt, 12 dB Cybernet. Let's go over to the attenuator and we'll read that off. And it has improved it. We've gone from 0.35 microvolts. So there's the 3, there's the 2. It's 2, 4, 6, 7 and a bit. We're going to call it 2.8. So 0.28. I wasn't expecting any improvement on that. In fact, we could have fixed it worse. Right, squelch time. Oh no, we'll do the meter. Turn the volume down a bit. So the meter needs to be reading bang on S9 with the 100 microvolt signal. It's just a tiny bit over. There we are. So with the preset there. Now we need to check the squelch. So we're going to turn the squelch to full. Let's make sure everything else is in the right position. So squelch is now full on the radio, so it's a matter of me going through the attenuators till we get to 100 microvolts, at which point I want it to open. So 1, 3, 10, 30. It's opened at 30. I want it to be coarser than that. So now it opens at 100 and not 30. So we'll now do the opposite. Go to the, I'm going to switch the signal generator to standby. That'll throw a red light up. Set the squelch on the radio to threshold. Switch the signal generator back on and see when it comes in. It's coming at 0.35 microvolts, dropping off about 0.29. So they're never the best squelch in the world, but they are competent. So there we are. That's the York 863, another very good working set. I'm just going to check deviation once more. 1, 2, 1. It's just gone over slightly. 1. There we go. Right. We'll put the lids back on. I've got about 4 DNTs of my own, DNT M40s. I bought one from Newark Radio Rally last year, and it looks to me new in box but faulty. Just the body only, not the mic. And that's going to be interesting to see why it's been faulty from new. Or, of course, is it one that somebody's attempted to put on 10 metres and ruined? But I've got about 4 of them, so that's something we'll run through, because it's difficult to set up on receive because you need to use 2 signal generators with it having a multiple crystal mixture arrangement. So we will do that, but I've got to get through some of these repairs. So we've got some forthcoming attractions. There's a Comtron 40F in this box, and there's something else as well. I think there's only 2 left in the box, and I understand one's a Comtron 40F. So I can't fail to like that. And then we've got when we finish the box, the next one is actually part of this batch, but it had to be sent in later because it wasn't ready in time for the gentleman to come up with them personally. And that is what I said to you yesterday, the Major 3000. Right, there we are. Let's put all that together. Let's unplug the... Did we ever check PA? I don't know if we did. I can't remember. Let's try it. So, that's a squelch. I did clean the volume control successfully. Until it next gets a whiff of fags. PA, it's on the mic again, I think, on these. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, it is. Right, we'll take the test equipment off and we will go over to the Antron 99 roof aerial, or whatever make it is. Oh, right, here we go. So it's about 1 o'clock. Roger. Lots of foreign interference because of weather conditions. There we are, we'll do an on-air test later on with that. So another Cybernet 134, this time a 1981 York JCB863. Thanks for watching.